Today we'll be doing section 512, solving equations by factoring. At any time during this program, please press pause if you need to note something. We'll go on to our first slide of vocabulary. We have three different vocab terms. The first one is the multiplicative property of 0. For all real numbers a times 0 is equal to 0. Please pause if you need to. We also have the zero product property. For all real numbers a and b, a times b is equal to 0. This is what we will be using today when we're solving. We'll set each of the factors equal to 0 like noted here. And then the last one is a polynomial equation, an equation in where both sides are polynomials. And we'll be starting with polynomial equations and using the zero product property to solve these. We'll move on to our first example. Our first example is a polynomial equation. Number 1 is x squared minus 4x minus 12 equals 0. The only difference is today we have an equals 0 there. Before we were using expressions. So we'll go through our checklist to see if there's a GCF, if there's a difference of two squares, a perfect square trinomial, factor add, factor add, or the grouping method. When I go through those 6 steps, I note that this is a factor add problem. So I am going to have 2 factors. I am going to be looking for factors of negative 12 that add to negative 4. So I would have 1 and 12. And remember, I can flip that negative back and forth. I have 2 and 6, 3 and 4. And I started with all the negatives on the first or the leading number. I could change that and say 1 and negative 12, 2 and negative 6, 3 and negative 4. When I look at those 6 combinations of factors, I see that 2 and negative 6 will add to my negative 4. So I will begin with my x's in the first place, plus 2 minus 6. At this time, I have it completely factored. So now I'll use the zero product property rule to find my solutions. Each one of these will be written as 2 different equations that I'll solve. So my first equation, x plus 2 equals 0. I'll subtract 2 from both sides. X equals negative 2 is my first solution. My second solution will be x minus 6 equals 0. I'll add 6 to both sides. So x will equal 6. There is my second solution for problem 1. Moving on to problem number 2, 3x squared plus 7x plus 2 equals 0. When I look at this one and go through our list of factoring methods 1 through 6, I find that this would be a factor add. So I'll have a factor of 3, factors of 2, that add to 7. Factors of 3, nice. 1 and 3 is a possible combination. Factors of 2, 1 and 2. So I'll begin here, setting equal to 0. I will begin with 3x and x. And then now I'm going to do the trial and error method. I will put in a 1 here and a 2. And they're both positive, a 7x and a 2. So I'm going to say, oh, these are both positive. When I check that with our smiley face method, I end up with 3x plus 2x gives me 5x. I realize that's not going to work, so I have to make a slight adjustment. So I'll go back here, and I'll go 3x. X equals 0. And now I will place the 2 in this location and the 1 in that. And I'll do our smiley face process. 3x times 2 is 6x. 1 times x is 1. 6x plus 1x is 7x. I do have this completely factored. Now I'll use the zero product rule. Set each factor equal to 0. and then I will solve. So I end up with 3x is equal to negative 1. X is equal to negative 1/3 for my first solution. I'll set the other one, x plus 2 is equal to 0. I'll subtract 2 from both sides. X is equal to negative 2. So I have my two solutions there. Here is our next slide. You'll want to pause and copy this information into your notes, and then we'll continue on to the example. Okay, looking at examples 3 and 4, you'll note that both of these examples are slightly different than the ones previously completed. You'll note that on both sides of the equation, we have a group of polynomials, but we need to have them in standard form. And what I mean by standard form, as on our last slide, is that this side or one or left or right side has to be 0. So I'm going to eliminate the 5k from the right side. When I eliminate the 5k from the right side, I end up with k squared minus 5k plus 10 is equal to 0. I now have this in standard form and in descending order. So I have k squared minus 5k plus 10. Now I'm ready to factor this. Again, I go through my steps for factoring. I note that this is a factor add problem, so factors of 10 that add to negative 5. I recognize right away that negative 2 and negative 2 and 5 is a possibility. And I also note that I could have a negative 1 and a negative 10 as factors. But when I look at both of these items that I have noted, neither one of these are going to add to a negative 5. So therefore, this is prime. So at this point, this is a no solution, since I can't factor it at this time. Moving on to number 4, I am going to place this in standard form, but I note right here I have negative 8x squared. The quadratic term is negative. I prefer to have them positive. So what I'm going to do is I am going to subtract the 8x and add the 8x squared to both sides. When I do that, I end up with 0 is equal to 8x squared minus 8x plus 2. When I rewrote it, I wrote it in descending order. First job, I go through, look through my first 6 steps, and I note that I do have a GCF. So I'm going to say 0 equals 2 times 4x squared minus 4 plus 1. When I look at the trinomial, I note that this first and last term is a perfect square. So I'm considering that this could be a perfect square trinomial. When I look at the square root of 4, I end up with 2. The square root of 1 is 1. And to find that middle term, I say 2 times 1 is 2, double it is 4. So I do have a perfect square trinomial. So I can factor this very quickly. Oops. Let me just put that back on there. Sorry about that. I am back. So I will factor this as a perfect square trinomial. I'll have 2x in my leading area, and then in the back I will have a 1. Since this is a negative sign, it is a minus on both of those. Now I have 3 different factors, and each one of them will be set equal to 0. 2 equals 0. That will never happen, so that's not a solution. I have 2x minus 1 equals 0, and then I have 2x minus 1 equals 0. Well, if you note, these two things are the same. Since they're the same, I only have to solve 1. So I'll have 2x minus 1 equals 0. I'll add 1 to both sides. 2x is equal to 1. X is equal to 1/2. My solution is x equals 1/2. Moving on to example number 5. When I look at this example, I already have it in standard form, and I do know that I actually have a GCF of 4. So I pull out the 4. When I pull the 4 out, I'm left with g cubed minus 15g squared plus 50g equal to 0. Now when I know here, I go back and I look and I'm looking for a GCF again. You notice I pulled out a GCF of 4, but I also have a GCF using the variables. So now I'm going to pull out that GCF. So my full GCF is actually 4g. When I pull out that, I'm end up with g squared minus 15g plus 50 is equal to 0. Now I'm looking at the trinomial, and I have to determine if I can factor that. So once again, this is going to be a factor add. So factors of 50 that add to negative 15. I have 1 and 50. And since I note that they have to add to negative, so I'll throw a negative on the 50. I have 2 and negative 25. And I have 5 and negative 10. Now, when I have my negatives here, I still need a positive 50. So I actually have negatives on both the negative 1 and 50, the 2 and the 25, and the 5 and the 10. So now when I look at those three factors, I end up with negative 5 and negative 10. Those two add to negative 15. So I come over here, I start out with my g, and I have a minus 5 and a minus 10. I now have three terms once again. I have 4g is equal to 0. I divide both sides by 4. G is equal to 0 is my first solution. My next solution, g minus 5 equals 0. I add 5 to both sides. G is equal to 5. And then my final factor, g minus 10 is equal to 0. I add 10 to both sides. And I end up with g equals 10. My final answer is g equals 0, g equals 5, and g equals 10. This is a cubic, so therefore I have 3 solutions to this problem. Today's homework is page 232, numbers 3 through 42, multiples of 3. If you have questions, please continue to now in class. Thank you.